Here in section 7.3 we will be working with the law of cosines. Before we do that, there are 5 things we need to keep in mind about triangles. Some of these are intuitive and some of them may not be, but the first one here we want to look at is that a triangle can have only one obtuse angle. And we want to keep in mind that obtuse means larger than 90 degrees. So it should make sense that a triangle can only have one angle that would be larger than 90 degrees. If the triangle does have an obtuse angle, which it doesn't have to have an obtuse angle, but if it does have an obtuse angle, then it has to be the largest angle in the triangle. And that should make sense as well. The longest side is opposite of the largest angle. The smallest side is opposite of the smallest angle. The last one may not be intuitive, but must be true that the sum of the lengths of any two sides must be greater than the length of the remaining side. So question 1, is the following information valid for triangle ABC? So we are given that angle A is 104 degrees. First of all, we notice that it's obtuse. And we know that our triangle can have only one obtuse angle. And if it does have an obtuse angle, then fact 2 says it has to be the largest angle in the triangle. And fact 3 says that if we have the largest angle in the triangle, the side opposite of it must be the longest side. Well, is this the longest side? And the answer is no. We are also given that side B is 31.3 meters, which is longer than side A. So this information is not valid for a triangle ABC. Okay, question 2. Is the following information valid for triangle ABC? Let's say that we have a side A, 3 inches, side B, 4 inches, side C is 10 inches. So let's look at this triangle. Let's see what it would look like. We'd have to have a side that's 10 inches long. We'd have to have a side that's 3 inches long, and then another side that's 4 inches long. When we look at this, we notice that when we add together these two angles, or these two sides here, when we add together these two sides, the sum of those two sides would be 7. And the remaining side would be 10. Well, what we said was for a triangle to be valid, when I add together any two sides, it has to be greater than the third remaining side. And it's not. So this would not be valid for a triangle. You can see that the sides 3 and 4 would be too short to actually form a triangle if it has a side that is 10 inches long. Alright, so here we're given this information that side A is 13.9 meters, side B is 9.8 meters, and side C is 11.3 meters. Which of these angles could possibly be obtuse? We want to keep in mind that a triangle does not have to have an obtuse angle. However, which one of these could possibly be obtuse? Angle A, angle B, or angle C? Well, we know that an obtuse angle is the largest angle in the triangle and has to be opposite of the longest side. So here we have the longest side. And so what that tells us, if side A is the longest side, then angle A has to be the largest angle. And the largest angle is the only angle that could possibly be obtuse within the triangle. So angle A is the only one that could possibly be obtuse. Doesn't mean that it is obtuse, means that it is the only one that could possibly be obtuse. Okay, question 4. Given the following information, which angle could possibly be obtuse? We're given that angle A is 41.4 degrees, side B is 6.7 centimeters, and side C is 13.8 centimeters. Well, we can cross angle A off the list. Angle A is obviously not obtuse. So we have to choose between side B and side C. Which one of these angles opposite of the sides would be obtuse, possibly be obtuse. And since this is the longer side, we would have to go with angle C as being the larger angle. So if any of them are going to be obtuse, it would have to be angle C that's opposite of the longer side. When we were discussing the law of sines, we had 3 congruence axioms, and 2 of those congruence axioms were side, 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 and side, angle, side. For those 2, there is not enough information to actually solve the entire triangle using the law of sines. So, for example, the law of sines would not be sufficient to solve if we knew 3 sides. We could not find angles A, B, and C if we only know 3 sides. We can't find them using the law of sines. So the law of sines would say that if we were looking for, let's say, angle A, we would have to form a fraction sine A divided by side A. So we have that. We'd have to form the fraction with B, so that would be sine B over side B, and then sine C over side C. So what we would see is that if I took any of these 2 fractions and set them equivalent to each other in an equation, that any of these 2 fractions set equal to each other would always contain 2 unknowns. And if I'm solving a single equation, I can only have 1 unknown. So the law of sines is not sufficient for us to solve if we know 3 sides. And we will also see that it's not sufficient if I'm solving a triangle if I know the side, and then an angle in between, and then another side. So to solve for these, we need law of cosines. And the law of cosines is different than the law of sines. It actually looks like a single equation. You'll notice that each one of these formulas has one of the angles by itself on one, or one of the sides by itself on one side squared. So we have a squared, b squared, c squared. And then what comes after is, you notice that we have b squared and c squared. So we have the other 2 sides being squared, added together, minus 2 times, and then once again, the 2 sides over here, b and c, are multiplied together times the negative 2, and then we have cosine of angle A. So what you're going to notice for all 3 of these is that the side that's being squared by itself on one side, the input angle for cosine will be the angle that's opposite of that side. So if this is a squared, over here you will have cosine of angle A. So if I have b squared in the formula, we will have cosine of angle B. We will have the 2 other sides squared, added together, minus 2 times the 2 sides that are on this side multiplied together. So it's basically the same formula for all 3, same pattern. Where does the law of cosines come from? To see where the law of cosines comes from, let's start with looking at our graph at an angle in standard position. So I'm going to put the vertex of the angle here at 0, 0, the origin, and we have our initial side and the terminal side. Let's call this angle B. Alright, so when we are finding sine and cosine of angle B, in order to find the trig function values, we would pick a point that lived on the terminal side. Let's call that point xy. And we would find the distance from the vertex, from the origin, to the point that lived on the terminal side, and we called that r. So the sine was y divided by r, so the y value of the point divided by the distance from the point to the vertex, so y divided by r, and cosine was the x value divided by r. So what we're going to do is we're going to take the information, we're going to write it just a little bit of a different way. We're going to form a triangle. And I'm going to call this point, we're going to call this angle C, and we're going to call this part of the triangle angle A. Now if we form this triangle, then we have sides. This would of course be side A, this would be side C, and this would be side B. Now once we define the angles of our triangle to be A, B, and C, the side C here is exactly the same thing as R. So in our formulas we're going to replace the C, we're going to replace the R with C. So that's y divided by side C, and this is cosine B is equal to x divided by side C. Now I'm going to rewrite, I'm going to multiply both sides by C to get y by itself on one side. So we have C times sine of angle B is equal to y. We're going to do the same thing over here. We're going to multiply both sides by C. So we get C times cosine of angle B is equal to x. Now what the law of cosines makes use of is the distance formula. And the distance formula says if you want to find the distance between any 2 points, so if I want to find the distance between, let's say, point C and point A, then we're going to use the distance formula to solve for the length of side B. So the distance formula, if I want to find the length or the distance of side B, that would be the square root of, and we need to find the distance or the difference of the x values of those 2 points. So we're going to be subtracting. Now, we already defined this point to be xy. Let's define this point here to be something. We need to know what the x and y value of that point is. Well, the y value, since we're on the x-axis, the y value would be 0. And we don't know the x value, but we do know that the distance from this point at the origin to this point, we do know that distance or that length would be basically described by side A. So let's call the x value distance A. So if I'm looking for the difference between the x values, that would be x from point A, and from point C the x value would be A. So here's the difference between the x values, and we're going to square it. Plus the difference in the y values of the 2 points squared. So we're going to keep the order. We're going to take the y value of point A, and we're going to subtract the y value of point C. So this is our distance formula. This is going to tell us the distance or the length of side B. Now we're going to do a couple of things here. We're going to square both sides. I want to get rid of that square root. So I'm going to come and I'm going to square both sides of this equation for this distance formula. We get b equals, and that is going to cancel out the square. So the square and square root are going to end up canceling each other out. Now I'm going to take what's underneath the square root, and I'm going to take this and I'm going to FOIL. This is x minus a times x minus a. And when I take that binomial and I square it or multiply it by itself, I get x squared minus 2xa plus a squared. And we're going to simplify this one as well, but y minus 0 is y, and then this just basically gives us y squared. So it's getting a little bit simpler. And the only thing I need is I need a b squared here since I squared both sides. Now we're going to make it look a little bit more interesting. We're going to take the definitions for x and for y. So over here we defined x to be equal to c times cosine b. So everywhere I have an x, I'm going to put in c times cosine of angle b. And that's x squared. Minus 2 times x, so that's c times cosine b in place of x, times a, we'll just leave that as a, it's side a there, plus a squared plus y squared. Now the definition that we gave for y was equal to c times sine b. So we're going to replace, everywhere we see an x and a y, we're going to replace that with our definitions that we formed for x and for y. Okay, once we do that, we're going to start to actually square the values. So now we have b squared is equal to, and if I take these two values and I square them or multiply them by themselves, c times c would be c squared, and cosine b times cosine b would be cosine squared b. And here we have negative 2 times c times cosine b times a. And I'm just going to rearrange. We have four things multiplied together. I'm just going to rearrange the way it looks. So I'm going to write this as minus 2 times a times c times cosine of angle b. We have our plus a squared. And then we're going to square this as well. C times c would be c squared. Sine b times sine b would be sine squared b. I'm going to rearrange the terms a little bit. The order of the terms themselves are not that significant, but I'm just going to rearrange them so that'll help us kind of visualize what's going to happen next. So I'm going to go ahead and I'm going to put a squared in the front. So I'm going to move this term to the front. And I'm going to bring these two terms to be next. So I'm going to put plus c squared times cosine squared b plus c squared times sine squared of angle b. And I'm going to put the minus 2a times c cosine b in the back. Now, it should start to look a little bit like our law of cosines that we started out with. We just have to do one thing here to make it look like the formula that we saw at the beginning. When I look at these two terms, I notice that they both have a c squared in common, so I'm going to factor out c squared. That leaves us with cosine squared b plus sine squared b in the parentheses. Soon as we do that, we notice that we have a Pythagorean identity. Cosine squared plus sine squared, this sum of those two values gives us 1. And 1 times c squared would be c squared. So here we get b squared is equal to a squared plus c squared minus 2ac cosine of angle b. And this can be done with the lengths of side A, side B, and side C. So this is where our law of cosines comes from. The general rule when we are solving oblique triangles, the general rule is to start out by seeing if you can use the law of sines. So if we can use the law of sines, then we use that first. The law of sines we solved using the congruency axiom SAA, so side angle angle, or angle side, or angle side angle. So we were able to actually solve those triangles using the law of sines. For the ambiguous case, we had a side side angle or angle side side. We also were able to solve the triangles using the law of sines, but sometimes we had to be careful that we examine the angle not only from quadrant 1, but also the angle from quadrant 2. So in the first example, we knew two angles, so there was no ambiguity. In the second section, section 7.2, we only know one angle, and there exists some ambiguity about what could come about for those other two angles. So we also wanted to look for quadrant 1 and also potentially for quadrant 2 angle that would work. And we said we could either have no triangle, one triangle, or potentially two triangles. So we just start by seeing if we can use the law of sines. If the law of sines is not going to work, then we use the law of cosines. And that will be true for side angle side. You won't have enough information to use the law of sines. And then for side, 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 we also do not have enough information to solve using the law of sines. So both of these will require the use of the law of cosines at the beginning in order to solve. In this first example, we are given the lengths of all three sides. So we have side, side, side congruence axiom. And we will be looking for the measures of the three angles. So angle A, angle B, and angle C. Since we're given all three sides, what we want to do is start by looking at the longest side, and we want to solve for the angle that is opposite of the longest side. So in other words, you want to look for the longest or the largest angle in the triangle first. So we're going to look for the largest angle using the law of cosines. So if we're going to solve for the largest angle, which would be angle A, we're going to use a law of cosines. We're going to use the formula that has angle A in it. So it starts with the side A. So A squared equals, and that's the other two sides squared on the other side. So A squared equals B squared plus C squared. And then we're going to do minus 2 times B times C. So it's the two sides that are right there being squared, so BC, times cosine of angle A. Now we know everything except for angle A, and that's what we're trying to solve for. So let's get cosine of A by itself on one side. So I'm going to go ahead and I'm going to subtract all of the terms that don't have cosine A in them. So we're going to rearrange this equation here to get that by itself. And since I'm multiplying negative 2 times B times C times cosine A, in order to get rid of minus 2bc, we're going to divide on both sides by minus 2 times B times C. Alright, so now we know to find cosine A, to find out what this value is, we're going to plug in all of the measures that we're given for angle A, for side A, for side B, for side C. We're going to square all of the sides, and then we're going to divide that by negative 2 times B times C. We're going to put that into our calculators, and we're going to find out what that value is. So we're going to find out what is the cosine value of this angle. And when I put this into my calculator, I get 0.1416345742. So I can go ahead and give you everything that I see in my calculator. Now this is an unfamiliar cosine value, so I will put this into my calculator. So I'm going to hit second button, cosine inverse, and I'm going to let my calculator store all of that, and I'm going to do second answer, and I'm going to put all of these digits into the inverse cosine function. I'm going to try not to round until the very end as much as possible. We're going to let our cosine inverse function tell us what this angle is. And my calculator tells me that cosine inverse of that cosine value gives an angle A of 81 point, we'll go ahead and round to the nearest tenth, so let's say 81.9 degrees. Now in the last section, there was some ambiguity. In other words, there were different possibilities for what the angle could be. Are there two possibilities for what this angle could be? Well, cosine is positive in which two quadrants? Cosine is positive in quadrant 1 and quadrant 4. Now, so we have another angle that has the same cosine value in quadrant 4. But do we want to use quadrant 4 angles? And the answer is no. Quadrant 4 angles go from 270 to 360, and this is way larger than we are allowed to have an angle in our triangle. Our triangle, all the angles have to add up to be 180 degrees, so I can't have a single angle be more than 180 degrees. So we will not use quadrant 4 angles. So for cosine, if the cosine value is positive, then we are only choosing angles from quadrant 1. So this is the only possibility for what the angle A could be. There's no ambiguity, no confusion. This is the only option that we have to choose from for angle A. And we solve for the largest angle because it's opposite of the longest side, so this is the largest angle in the triangle. Now we want to solve first using the law of cosines. We want to first solve for the largest angle, because what we're going to do next is we're going to solve for the other angles using the law of sines. So now we know angle A. We're going to use the law of sines to solve for angle B or angle C. Let's solve for angle B. So now we know that the sine of A, so now we know that A is 81.9 degrees. And then we know that side A was 9.3 centimeters. We don't know angle B. And we know, though, that side B was 5.7. So now we can use the law of sines to solve for the other angles. And once again, we won't have any ambiguity here as well, because we know that the angle B has to be smaller than 81.9. Alright, so we're going to multiply both sides by 5.7, and we get sine B is equal to 5.7 times sine of 81.9 degrees divided by 9.3. So we get sine B is equal to, I get 0.606724558. So put that into the inverse function. So sine inverse of all of that. So let your calculator store that for you so you don't have to retype it. And our calculator tells us that the angle that we are looking for from quadrant 1 would be 37, we're going to round to the nearest tenth, say 37.4 degrees. Now, once again, we want to emphasize the point here that we have already found that angle A was the largest angle, 81.9 degrees. We solve for the largest angle first, using the law of cosines. So that way, when we get to the law of sines to solve for that next angle, there will still be no ambiguity. So there's only one thing it could be. It can only be 37.4 degrees. You might say, well, sine is still positive in quadrant 2. But remember that the quadrant 2 angles, there is an angle in quadrant 2 that has a sine value that is positive 0.6, 0.6, etc. But if it comes from quadrant 2, it has to be between 90 and 180 degrees. Well, if we were to choose an angle from quadrant 2, we would have a problem because we already said that angle A was the largest angle. So angle B cannot be larger than angle A. And if I go for a quadrant 2 angle, that quadrant 2 angle that would describe B would be larger than angle A. So we're not even going to look in quadrant 2 because we already know that angle B has to be smaller than angle A. So we can rule out quadrant 2. Now, what's really nice here is once we know 2 angles, then finding the third angle is really easy. All we have to do is subtract the 2 angles that we have from 180 degrees. So 180 minus 81.9 degrees minus 37.4 degrees. And we find that angle C has to be 60.7 degrees. So we want to solve the following triangle, and we see that we are given, once again, the measures of all 3 sides. We have side, side, side. So we will need to use the law of cosines to solve for the 3 angles that we don't know. So we want to find angle A, we want to find angle B, and we want to find angle C. So the law of cosines is required here. And when we are given all 3 sides, what we want to do first, and it's important that we do this first so we don't introduce any ambiguity, is we want to solve using the law of cosines first. We want to solve for the largest angle. So we look for the longest side. So if this is the longest side, that says that we want to solve first for angle C because that will be the largest angle. So this angle could potentially be obtuse. In other words, it could potentially come from quadrant 2. And so we're going to use the law of cosine so there's no ambiguity. We know exactly it either has to come from quadrant 1 or quadrant 2, no doubt about it. So if we want to solve for angle C, then we need to use the cosine formula that starts with C. So C squared is equal to A squared plus B squared minus 2 times A times B times cosine of angle C. So we're going to start by rearranging the formula to get cosine C by itself on one side. So we'll subtract A squared and B squared. You could also plug all of the values in and then rearrange. Either way would work. I'm just going to go ahead and solve to get cosine C by itself on one side first. And then, of course, divide by minus 2 times A times B on both sides. And that'll give us cosine C by itself. And we're going to go ahead and plug in our values. So side C, 62.7 squared, minus side A, 42.9 squared, minus side B, 37.6 squared. Type that into your calculator first, then hit enter, and then divide by parentheses. When you put it in your calculator, put the parentheses in. So we're going to hit enter for the top, and then parentheses, divide by parentheses, negative 2 times side A times side B. And then important in your calculator that you hit the close parentheses and then hit enter. Plug everything into our law of cosines, and now we're going to figure out in our calculator what that cosine value is. So in my calculator I get negative 0.209889414. So the cosine value is negative. So we're going to think about where cosine is negative. Cosine is negative in quadrant 2 and quadrant 3. Do I want to even try to find the angle from quadrant 3? And the answer is no. So we're only going to find the angle in quadrant 2. The angle in quadrant 3 is going to be too large. It'll be between 180 and 270, and that's too large for an angle within our triangle. So we are going to ignore that angle and only focus on the quadrant 2 angle. So we're going to put this value into our cosine inverse function, and then we're going to solve for angle C. So the calculator should tell you an angle for quadrant 2. So it tells us that C is equal to 102 let's say 0.1 degrees. So here's the largest angle. And notice that it is obtuse, is the largest angle, and it is obtuse. Now they don't always have to be obtuse, but in this example it is. Now that we have the largest angle, we are going to go and solve for one of the other angles. Let's solve for angle A. It doesn't matter which one. Let's solve for angle A using the law of sines. So if I'm solving for angle A, so let's say sine A divided by side A, and side A was 42.9 equals, and then we're going to use the angle that we know now, angle C, divided by side C, which was 62.7. Okay, we're going to multiply both sides by 42.9. And we will find that sine A is equal to, and in my calculator I get about 0.668, some other values, so just let your calculator store that. And we're going to let the calculator tell us what that is. So we're going to put that into the sine inverse function and let our calculator tell us that angle A is about 41 point, we're going to round to the nearest tenth, and I get an angle that looks like this. So when I round to the nearest tenth, that would actually turn out to be 42.0 degrees. Now, am I going to bother looking in quadrant 2? So I want to make sure we understand this. We found an angle in quadrant 1, 42.0 degrees. The sine is not only positive in quadrant 1, it's also positive in quadrant 2. So we have another angle in quadrant 2 that has that reference angle, 42 degrees. Do I even bother looking for that? And the answer is no. I'm not going to bother with that one because we already said that angle C was the largest angle, and there can only be one obtuse angle in the triangle. So since I already have one obtuse angle, then we cannot have another obtuse angle for angle A in our triangle. So angle A, the only option we have is 42.0 degrees. So once again, no ambiguity. We avoided that by solving for the largest angle first. All right, now that we know two angles, we can find the third angle B by just subtracting from 180. So 180 minus 102.1 degrees minus 42.0 degrees. Find that angle B is 35.9 degrees. Okay, now we have all three of our angles. We start by using the law of cosines first, with the largest, solving for the largest angle, then use the law of sines to solve for either of the other two, and then lastly, solving for the third angle, simply subtract from 180. In the last two examples, we will look at solving a triangle if we are given a side, an angle in between, and then another side. First, I want to demonstrate that the law of sines is not sufficient. So if we were going to solve using law of sines, let's form our fractions. That would be sine of angle A divided by side A, which we don't know, and then sine of angle B, which is not given in this example, divided by side B, which would be 2.78. And that would be equal to our last fraction with C would be sine of angle C divided by side C. So when you look at the three potential fractions that we would set up for law of sines, we see that any two of these fractions, if we set them equal to each other in a single equation, the fractions would also present with two unknowns. So we would have two unknowns in the equation, and we can't solve a single equation if we have two unknowns. So the law of sines is not sufficient. So that's why we are using the law of cosines here to solve for the unknown parts when we are given side, angle, side. So we're going to use the law of sines, and the first thing that we're going to do is find the length of the third side. So we know two sides, so we know side B and we know side C. We first want to start out by finding the length of the third side. So that side would be side A. So A squared equals, and that's going to be B squared plus C squared minus 2 times B times C times cosine of angle A. So the side we start with is the angle that we end with. We're going to plug everything in. Now what's nice about solving for a side is we can just keep the formula exactly as it is. We're going to plug in side B squared plus side C squared minus 2 times B times C times cosine of angle A. And we actually know what angle A is, 41.4 degrees. So we're going to put that into our calculator basically exactly the way that is written here. And we find that A squared is equal to 6.745979215. Now we're going to leave that in the calculator so we don't have to retype that, and then we're going to hit the square root button. We're going to hit square root, and then we're going to hit second answer. We're going to take the square root of both sides here. Let the calculator store everything in as much as possible. Side A, then we should get a value 2.5973022296. And it's important here, we don't want to round until the very end if possible, so I'm going to keep several decimal values when I go to solve further. We don't want to have any rounding errors, so we're trying to avoid that as much as we can. But we do know that side A, and let's go ahead and round to the nearest two decimal places here for this. Side A would be about 2.60 yards. So we know side A. We still need to figure out what is angle B and what is angle C. Now, the strategy for the next part here is to avoid any ambiguity. We're going to use the law of sines to find these two angles, either angle A or either angle B or angle C. We're going to use the law of sines to find one of those two angles. The strategy here is to find the smaller of the two remaining angles. I want to find the smaller of the two. If we look for the smaller of the two, we know for sure that the smaller of the two cannot be obtuse. So that means that we're only looking for an angle in quadrant 1. That'll eliminate any ambiguity of should we look in quadrant 1 and quadrant 2. We know for sure that the smaller angle would have to come from quadrant 1 because it's smaller, cannot be obtuse. So we're going to solve for the smaller of the two. And the question would be, which one is the smallest? So of the two remaining angles, side B is the shorter of the two sides, so angle B would be smaller than angle C. So we're going to solve for the smaller of the two using the law of sines. And we don't have any ambiguity because we know for sure that it has to come from quadrant 1. So we now know angle A and side A. So we're going to set up one of our fractions using the law of sines. Sine of angle A, which is 41.4 degrees, divided by side A. And I'm going to use, even though we rounded for our answer, I'm going to use as many digits as I can here. I'm going to go ahead and say that side A is 2.59730. You can even leave that in your calculator. But I'm going to go ahead and use as much as I can so I don't have a rounding error when I go to solve for this angle. We're solving for angle B, so that's sine of B divided by side B, which is 2.78 yards. Okay, we're going to multiply both sides. We're going to multiply both sides by 2.78. And put that into our calculator to figure out what sine B, what is the sine value of angle B. And I get 0.707829423. And we're going to let the calculator tell us what angle from quadrant 1. So sine inverse, we're going to feed this into the sine inverse function to solve for angle B. And the calculator tells me that angle B would be approximately, we'll go ahead and round to the nearest tenth here, 45.1 degrees. Now that we know two angles, then solving for that last angle, solving for angle C, we are going to subtract from 180. So 180, we're going to subtract angle B and subtract angle A, which was 41.4 degrees. So we get that angle C is 93.8 degrees. And notice that this is an obtuse angle, and we avoided any confusion by solving for the smaller angle first. So that's the strategy for side angle side, is first use the law of cosines to find the third side, then use the law of sines to find the smaller of the two remaining angles. That way we know there's no possibility of this angle being obtuse, and we're only looking then in quadrant 1. And then subtract both of those angles from 180 to find the remaining angle. In this last example, we want to solve the triangle that has angle B with 42.3 degrees, side A 12.9 centimeters, and side C 15.4 centimeters. Let's draw a triangle so we can see what congruence axiom we might be working with here. So we're told that angle B is 42.3 degrees. So this is side B. Side A, we're told, since it's here, we're told that that is 12.9 centimeters. And side C is 15.4 centimeters. So what congruence axiom are we working with? Well, we have a side, and then we have an angle, and then we come to another side. So this looks like it's side, angle, side. And we know that side, angle, side is solved by first using the law of cosines. So we're first going to solve for the third side. So we know side A and we know side B, so we want to solve, or side C, we want to solve for side B. So B squared is equal to, we're going to use the formula that starts with B, A squared plus C squared minus 2 times A times C times cosine of angle B. Remember, the side that I start with is the angle that I end with. And we're going to plug in all our values, so 12.9 squared plus 15.4 squared minus 2 times A times C times cosine of angle B. And cosine of angle B, so angle B is 42.3 degrees. So what's nice, once again, is since we're solving for a side, all we have to do is put this into our calculator basically exactly as we see it. And I get that b squared is 109.6997733. And once again, we're going to leave that in our calculator and then take the square root of that number. So we get b itself is equal to 10.47376596. So we know side b, and we'll round to the nearest tenth, so that would be 10.5 centimeters. So now we know all three sides. The next thing that we're going to do is we are going to solve using the law of sines. We're going to solve for either angle A or angle C. And now we talked about a strategy for eliminating any ambiguity. We want to solve for the smaller of the two angles first. That way we know for sure that it has to come from quadrant 1. So when we look at sides A and side C, which one of these is smaller? Well, that would be side A. Since side A is smaller, then angle A will be smaller. So we're going to solve for angle A. So because we know angle A is smaller than angle C. And if angle A is smaller, of course that means that angle A is not obtuse. So C could possibly be obtuse, but A we know for sure is not obtuse. And that means that it has to come from quadrant 1. So when we use the law of sines, there will be no ambiguity. So since we're solving for angle A, we're going to use the law of sines. We're going to write out our A fraction, so that's sine of angle A divided by side A, which was 12.9, equals, we don't know angle C, but we do know angle B, so we're going to use angle B here. Sine of angle B, which was 42.3 degrees, divided by side B, which we're going to use the unrounded version here. At least go a few digits past what we're going to round to. So I'm going to use as many as you can there, plug them in. And now to solve for angle A, we're going to multiply both sides by 12.9. So now we have that sine A is equal to, we're going to put all of this into our calculator, and what we should get is about, say about 0.828 9149727 approximately. And we don't know that sine value, so we will definitely be using our inverse function. Let your calculator store all of that for you, put it into the inverse function, and it should tell us that angle A is approximately, let's go ahead and round to the nearest tenth. I get 55.987 and so on. So if I'm rounding to the nearest tenth, it looks like we get about 56.0 degrees. Alright, remember that we're not looking in quadrant 2, we're only looking in quadrant 1 because this is the smaller of the two remaining angles, therefore cannot be obtuse. Okay, once we know two of the angles, we can easily solve for the third by subtracting from 180. So the remaining angle C, we're going to subtract from 180, we're going to subtract 56.0 degrees and 42.3 degrees. So our angle A and our angle B. And we find that the remaining angle C must be 81.7 degrees.